Alrighty, good evening, Algebra 2. Today we're going to be talking about continuous growth or decay, which we actually just spent two whole sections talking about exponential growth and exponential decay. So as we saw, exponential growth grew very quickly and decay declined really rapidly and then kind of flattened out. So we want to take this and I want to kind of apply this idea to money, which you're already probably thinking, oh, wouldn't that be nice if we had exponential growth for money? And why, yes, it would. So let's actually talk about what that would look like. So if you recall the general compound interest formula, which you had to know for a couple tests ago, it was A equals P times the quantity, 1 plus R over N to the NT power. Let's actually define what these variables were again, just to make sure that everybody remembers. Remember, A was the amount after a certain time, so amount after whatever time had elapsed. P was our principal, so our principal amount, so what we started with. R was our interest rate. N, and both these N's were the same thing here, was the number of compoundings we did per year. So remember we had annually, semi-annually, quarterly, monthly, etc., etc. So that was what that was about. And T was the amount of time in years the money was left in the bank. Okay, so let's take this following scenario. It says, suppose a bank pays 100% interest annually. Don't we wish? I wish they would. And let's just say you put $1 in there. So as you know, the number of compounding periods within the year increases, the amount you earn increases. Okay, so we kind of discovered that the more compoundings you had per year, the better our money looked at the end of that year. So let's go ahead and actually set up this equation before we leave this screen to model the fact that we're getting paid 100% interest and we've only put in $1. Okay, so A is just going to be A. We don't know how much we're getting out. Our principal amount, you guessed it, is just simply $1. And then plus 1, times the quantity, 1 plus, and then R was our interest rate. Well, we're getting 100% interest, so remember, 2 places back would give us 1, or 1.0, whatever you want to put here. So 1, let's put 0.0 so we can kind of tell that it's an interest rate. So 1.0 over the number of compoundings. Well, again, we don't know what that is yet. We're going to take a look at that in a second. And N is still N here, and then we do not know how long we're leaving it in there, okay? So we're going to put T in here for now, okay? So this is our formula we're going to use. A equals 1 times 1 plus 1.0 over N to the NT power. Okay, so we're going to use that. We're actually going to use that to fill out a chart. So make sure you have that written down. Okie dokie. So it says copy and complete the table below to show the value of A at the end of 1 year, T equaling 1, for successively shorter compounding periods. Okay, so we already know our principal amount was $1 and our rate was 100%. So that was the stuff we took from the other screen. So we're going to basically set up another equation, much like the one we just did, and we're going to put all of these things in here. But now we also know T, that's going to also come into play here. Okay, so take a second, copy down this table. We have our type of compounding over here. We're going to have annually, semi-annually, quarterly, monthly, daily, hourly, and by the second. Holy cow. And then number of compoundings per year, we'll figure that out in a second. Here's our formula, and here's what we end up with for A. So you have 4 columns and a whole bunch of rows here. So go ahead and pause the video and actually write these out. Okay, so I want to see everybody's table tomorrow. Okay, so the easiest column to fill out would be this N, the number of compoundings per year. So let's go ahead and do that first. Annually, we know that that's only going to be 1 time we're compounding interest per year, so that's why there's a 1 here. Remember, semi-annually meant twice a year. Quarterly, well, there's 4 quarters in a year, so we have a 4 here. Monthly, how many months are there in a year? That would be 12. Daily, how many days are there in a year? Well, that would be 365. Yikes, hourly. Now you might be thinking, ooh, there's 24 hours. Yeah, but that's 24 hours in one day. So what we'd have to do is do 24 hours times the 365 days we have. And that's what we get by the hours. So 8,760. And then by the second, oh boy. Okay, so we're up to hourly now. So then we need to say, okay, there's 60 minutes in an hour. So we need to multiply that by 60. So that would be by the minute, but then we want by the second. So we have to multiply it by another 60 because there's 60 seconds in 1 hour. Holy cannoli. Okay, so let's place our commas. Okay, so it'd be 31,536,000 seconds in 1 year, which is a lot, but hey, they're seconds. They're very small periods of time. Alrighty, so let's go ahead and set up. I'll set up the first couple for you, and then I'm going to leave it to you guys. So A equals P. We know our principal was $1, so we say 1, and then times the quantity, 1 plus. Our rate was 100%, which remember we had to change that to a decimal, so it's really just 1 over N, which is going to change every time because we have different compoundings for every type we're doing. Here, our compounding, we're only compounding it once a year, so 1 over 1. And then N again is 1 up here, and guess what? Our time is also 1. So guess what? This is a lot of ones here. So let's think this through. We start in parentheses, and if you need to, we can do this. No. No, no, no. I don't even feel right about that. Let's just do this mentally. 1 divided by 1. Well, that's 1. 1 plus 1, well, that's 2. 2 to the, well, this is 1 times 1, so that's 1. So 2 to the first power is still 2. And then 2 times 1 is 2. So how much money would we end up with at the end? Well, we'd have $2. Okay? Which makes sense because they're giving us a 100% interest rate. We only had $1 in there, so they're gonna match basically what we have in there. So they're gonna give us $2. Okay? Let's go ahead and set up semi-annually. So A equals 1 times the quantity. Excuse me. 1 plus 1. Our rate's still the same. The thing that changes is our number of times we're compounding a year, so N. Now N, we're compounding twice a year, so 2. And then we have N again, so that changes to a 2 times 1 because we have 1 year, we're leaving it in there. Okay? So now this one, we still don't really need a calculator, but let's go ahead and just so everyone can follow along. So we start, whoops, sorry. Let's clear that out. Inside the parentheses, 1 divided by 2, well that's just 1/2, but if you want, go for it. 1 divided by 2 plus your 1, we're still in our parentheses here. So we've done this. What's in here is 1.5, and then we of course order of exponents, do exponents first. So to the second power, because 2 times 1 is 2. And then we multiply that by our 1, which is our $1 that we had in there to begin with. And we get 2.25 as our amount. So $2.25. Okay, let's get rid of this guy. Let's go ahead and do a third here. So here we go. A equals 1 times the quantity, 1 plus 1 over. Now we're changing our times we're compounding a year to 4. So 1 over 4 to the 4 times 1 up here. Alright, so let's grab this guy again. So we do in parentheses first. So 1 divided by 4. I always start here. It's way easier for me. And then I add a 1 to it. That's all in the parentheses. Now we're taking it to the 4th power and multiplying it by 1 in the end, which you can really skip this step because multiplying it by 1, look, didn't do a darn thing. Alright, now I know that typically we always write just to the cents because that's what makes sense. Haha, get it? For dollars. But at this point, because we're going to discover something important here, I would actually want you to write out pretty far here. So let's go 4, 4, 1, 4, 0, 6, 2, 5. Let's just go the whole way. So from here on out, whatever they give you, you got to write down. Okay, so make it work. All right. Okay, now there's 4 of them left. I want you to pause the video and I want you to do them all. I want to see all of these written out with your proper compoundings in here, and then do the correct arithmetic on your calculator, and hopefully you'll get to the right A's here. Okay, so go ahead and pause the video and make sure that gets done, please. Okie dokie. So hopefully you've gotten your last 4 columns. Fill it out here. So you should be having double check all your stuff. So the answers are 2.61303529, 2.7146456742, etc., and you get down to here to 2.718282473. Okay, what's happening here is, you notice we had $2 at the top, and then we had 2.2, and then we had 2.4, 2.6, 2.7, 2.7, 2.7. So they're all approaching this 2.718 number, which is actually an incredibly special number here. What this number is this number, not this particular one, but this whole situation is approaching that number. So we're going to get closer and closer for every interval. We compound it quicker. So if we did by the second, then let's say we did by the millisecond, then the nanosecond, etc., etc. We get closer and closer and closer to this number that we call E. Okay, and this E is much like the number pi. Remember our pi from before. It's irrational. It never ends. It never repeats. It never stops. It's just a different number. So instead of 3.14159, blah, 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 it's 2.71828, blah, blah, blah. Okay? So we're going to talk about that number a little bit more here in the next video. So please make sure you tune in.